doesn't
Okay,
work.
Bennett.
What?
Can you come closer, see if we can see it? Okay, this is Bennett. Can you wave hi? We're going to try to talk about a mole today, and he's going to be my student that I have a question. So, the warm-up that you saw in the portal was we have to rank a mass of 1 dozen pencils compared to 1 dozen elephants. So, do we think that the mass of 12 elephants is the same as 12 pencils?
No.
Do we think the mass of 12 elephants is greater than 12 pencils?
Yes.
Why do you say that?
Because the elephants, if you have 12 of them, a dozen of them, they weigh a lot more than only 12 pencils.
Yeah, that's good. So how much do we think 1 pencil weighs?
About
like
half a pound.
5 grams?
Half a pound.
We'll say maybe a mass of 1 pencil is like 10 grams. What's the mass of 1 elephant?
About, I'd say 500.
Grams?
Yes.
It's probably like 1 ton.
Is that
Which
the same
equals
as 500?
a lot.
1,000.
Grams.
1,000 grams?
Okay, so what's the same about 12 elephants and 12 pencils?
They both have a dozen.
Good. So if I had a mole of elephants and a mole of pencils, how many pencils would I have, or how many elephants would I have?
6.022.
Times 10 to the 23rd. Good. If I had a mole of pencils and a mole of elephants, would they have the same mass? So elephants and a mole of elephants and a mole of pencils would weigh the same?
No. Yeah, they would.
What's the same about a mole of elephants and a mole of pencils?
They both weigh 6.022.
Do they weigh that many, or is there that many on the scale?
They weigh that many. There's that many on the scale?
Yeah, there's that many on the scale. So there would be 6.022 times 10 to the 23rd elephants on one scale, and 6.022 times 10 to the 23rd pencils on the other scale.
Oh.
Would that scale be balanced?
No.
No. Good. Why?
Because the other elephants are still heavier.
Yeah, they're so much bigger than 1 pencil. Good. So I have the same amount of them. Okay, so instead of elephants and pencils, we're going to look at chemicals. So for example, in this beaker, and I'll bring the video up here so you can see it better, I have copper, and this one I have sugar, and this one I have salt.
And this one you have liquid.
Liquid what?
Water.
Water. Good. So why do these all look different?
They all look different because some of the particles are bigger and some of the particles are smaller.
Good job.
But they all have the same amount of particles.
How do we know they all have the same amount of particles?
Because this one, it's 1 mole.
Yeah, it's 1 mole in each of them.
Yeah, there's 1 mole of each of them. And they all look different because these have bigger particles, less particles than, not less particles, but
Less size of particles.
smaller particles.
Good.
And then this one has the smallest particles.
How do you think I can tell the size of a particle?
You can't.
I know you haven't learned this yet, but my students would know to look at the size of a particle, like copper. How do I know how big a copper particle is? I just use the periodic table. So copper has a mass of 63.55 grams for every 1 mole. But that also means 1 copper particle has a mass of 63.55 grams, or I guess 63.55 AMUs. No, you're doing good. So if I wanted to figure out the mass of 1 water particle, how could I figure that out? What would I have to look at?
That thing.
Yeah, periodic table. If I want to figure out how many particles are in a mole, that's always this number, 6.023
6.022.
times 10 to the 23rd.
Anything.
Of anything. But if I want to figure out how much mass does that 1 mole of a substance contain, that's from that number on the periodic table. So you can also see that's why that number is so cool. It represents the mass of 1 mole of anything, but it also represents the mass of a particle. So that you can see these better, I'm going to bring that camera up here and you can see the difference between, remember all of these have the same amount of particles in them.
But
How much is
some
in each of these?
12, but
Not
some
12, they're not a dozen.
oh.
Why couldn't we use a dozen? That's a good point too. Why can't I use a dozen particles? Like why do I need a number that's so big?
Because they're so small.
Yeah, high five. Particles are so small. We can't see them, so we need a huge number to be able to see them. This is how big a mole is.
They all have 6.022 in them.
Good job.
But this one, these are bigger, and then these ones are smaller, smallest.
Okay, so I'm going to zoom the camera up here for you to look at these, and then you're going to use these samples to help you answer the front and then the back of your What is a Mole worksheet. So for the What is a Mole, remember if you're trying to figure out how much mass would a mole that sample have, you look on the periodic table. If they ask you how many particles are in a mole, that's always 6.023 times 10 to the 23rd. Do you think they have any other questions? What's your question? Well, apparently our science lesson today is going to be how the periodic table works, which you guys already know, so we'll talk about that later. Okay, I'm going to zoom in and help you with your worksheet. If you have any questions, please just email me or come to office hours.
Can I do
Here, help me
it?
zoom in.
Do it. Oh, 5 battery. You
It's
need
okay.
to charge this.
This is 1 mole of copper.
This is 1 mole of sugar. This is 1 mole of,
Salt.
and this is 1 mole of water.
And how did I figure that out? All right, here's all those. Remember, I just went to the periodic table, figured out their mass for 1 mole, put that on a balance that I have at my house, and then we gave the samples to you. Okay, good luck learning.